Hi everyone, in today's video we will work on the problem, and you see here one inequality, and we'll just try to see that whether this inequality is true or not. First of all, before starting the problem solution, I want to share one inequality which is very famous throughout the Olympiad world. This is called Cauchy-Schwarz inequality, and I will try to prove this inequality in terms of just two variables, two terms. Let's write it first of all. The inequality claims that a square plus b square is greater than or equal to 2ab, and a and b here can be are related to the natural numbers. And let's try to prove it. And actually proof of this inequality is very easy, but it is very useful while solving the inequality problems during Olympiad problem solution. A minus b square is greater than or equal to 0. It's very simple because it's quadratic term, and even if it is minus a negative number, this will give us the positive one, and in the minimum we will get 0 in the brackets, and the square will be equal to 0 when a is equal to b. This term you see here will be equal to 0. And let's just open the brackets. A square plus b square minus 2ab greater than or equal to 0, and a square plus b square greater than or equal to ab. We proved the theorem. And coming to our inequality, let's try to solve it. And let us think that how can we start solving this question. And let's start. X to the power 4 plus 49 divided by x squared is greater than is greater than or equal to 14, and x is not 0 here, and x squared term will be greater than 0 because it will give us always positive numbers, and if the x is not equal to 0. And let's just replace x squared with t squared plus 49 divided by t greater than or equal to 14, and just divide it into two fractional number, t squared divided by t plus 49 divided by t greater than or equal to 14. It will not change. And let's just cancel out 1t here, t plus 49 divided by t. Let's change the side of 14, minus 14 greater than or equal to 0. To find this this function's minimum result will just make us solve this problem easily, because it just claims that the minimum value of this function is equal to 0. And to find the minimum of the function, we covered in one of our videos that we use derivative. Let's call this function ft. The derivative of ft with respect to t, it can be shown the ft dt, and it is equal to the derivative of t is equal to 1, derivative of 49 multiplied by t to the power minus 1 will give us the minus will come to the front of this term, multiplied by 14, t to the minus 1 minus 1. And 14 is the constant term, therefore its derivative will give us 0. 1 minus 49 divided by t square is our derivative. And to find this function's minimum or maximum, right now we don't know whether we will find the minimum value or maximum value. You should equalize this term with 0. 49 divided by t square is equal to 0. 1 is equal to 49 divided by t square. T here should be equal to plus minus 7, but we know that t is equal to x squared and this term is greater than 0, therefore t is equal to 7 in our case. And to find whether this is the maximum value or minimum value, we should find the second order derivative of the function. Let's find the second order derivative of this function. 1 minus 49 t to the power minus 2. The derivative of this function with respect to t can be shown this way. And again, the 1 is constant term because it will be cancelled out to 0. Minus 2 will come here, plus 2 multiplied by 49. Minus 2 minus 1 minus 3. T to the minus 3, and this is the result. 2 divided by 49 t in cubes. And to just we should place what we found, the value of t here in place, and we will get the value greater than 0, which shows that we found the minimum value of the function and as we see that the minimum value of the function at point 7, let's place the 7 here when we found the term x squared is equal to t. X squared will be equal to 7, x will be equal to square root 7, not minus 1, because we just actually it can be minus, because we just exceptional case is when x is equal to 0, plus minus. Again, it doesn't matter actually, because our terms here are quadratic to the fourth power and quadratic. And when we write it, it will give us the 49 plus 49 divided by 7 greater than equal to 14. 7 multiplied by 14 is 98, and this is 98. When the x is equal to plus minus square root 7, we get the minimum value of our function, and which is equal to 98, equal to 98, which means that we can just claim that and say that this is true. But how can we solve this problem more easily using the Cauchy-Schwarz equation that we proved before starting to solve this problem? A squared plus b squared greater than or equal to 2ab, and we claim that a, b can in the array of natural numbers, or it can be told that, which is positive, it can be told that it is positive, they are positive integer numbers. And let's write our problem again. X to the power 4 plus 49 divided by x squared greater than or equal to 14, and greater than or equal to 14. And let's just divide our number into two fractional numbers, x squared plus 49 divided by x squared greater than or equal to. Let's refer to our first inequality, Cauchy-Schwarz inequality, 2 square root a squared and square root b squared, second term, 2 square root x squared and multiplied by square root, the second terms should be written here, 49 divided by x squared. Let's just get our terms out of the square roots, and we will get 2 multiplied by x multiplied by 7 divided by x, and we get 14, which means that we could prove inequality in a more simpler way compared to the first method that we used. And I think that this video was beneficial for you all. If you like my video and if you could learn something, please subscribe to my channel.